Now let's see how we can apply these concepts to copying the runes into place. So we have the runes, they've been centered, and right now they have, let me press F. So right now they're kind of facing backwards. Okay, we want them to be aligned towards the z-axis because we know that that's the axis that's going to be facing the normal. So let's create here a transform. And we'll rotate this along this axis, the x-axis, 180 degrees. So now they're facing along the z-axis. So they're going to be facing correctly towards the normal of those faces. Now let's check out what we have here. So far our hammer is like this, and we want to copy the runes to these faces. We can actually grab those faces easier if we go all the way up here while they're still not divided, and it's easier for us to select those. So let's grab them there. I'll type S, making sure I'm in primitives, and I'm gonna select these 4 on this side and the other 4 on the other side. Now that they're selected, I'm just gonna be pressing delete. When you press the delete key, it's gonna automatically add a blast node to your flow. I'm gonna shake it off so it disconnects, and I'm gonna just making sure that the blast is not included on the flow that was supposed to be coming down and giving us the final result. Okay, we don't want this blast to interfere with what we have done before. Now the blast is basically a simplified delete node that actually has the option for us to delete what's not selected. Here we're selecting, these are the primitives that we're selected. If we turn on delete none selected, then it's going to be the reverse, and we're going to be keeping these faces. We know we want to align the runes with the normals of each one of these faces and with the center of each one of these faces. So let's first make sure that they have normals. Let's create a normal. Let's have a look at those normals. Let's make sure that here on this normals operator, we actually add the normals to the points. Great, so now we know the faces have the proper normals, and the z-axis of our runes are going to be, let me make them visible. So we know the z-axis of our runes is going to be aligned with the normal of these faces. We still can't work with these. I'm actually going to copy this to this side so it's closer. We can't start right away copying the runes to these points because we have too many points. We want just one point at the center of each one of these primitives. And for us to reach that, I'm going to use an operator called primitive. And this operator basically goes through each one of the primitives and applies a transformation. It can apply a transformation. In this case, I just want to make sure that it scales down all the way to 0. Each one of those primitives. And now it looks like I only have the 8 points that I need. But if we middle mouse button here, you'll see we still have the 32 points. And we just want 1 point on each one of these locations. So we kind of have to weld all the points together. We're going to make them collapse onto each other using a fuse operator. The fuse is going to collapse them all, but if you keep all the options on, we need to disable this version, just make sure this option, just make sure that it doesn't really remove all the points. And now if we middle mouse button here, we see we have the 8 points that we were looking for. The next step is disable the pre-compute affected normals. We don't want it to affect the normals that we already had. This way we can see we still have the normals. Let's have a look at them. They're not showing. Let's have a look at the values of these normals. I'm going to expand the geometry spreadsheet here. Right away you can see that these aren't regular values. We know the normal has to have usually will have a length of 1, and right now we have astronomical values here. So we're going to apply a normal, but on a different way than we usually do. We don't want it to compute normals, we just want to make sure that the normals are unit length. And that fixes it. So now we have regular values and we can have a look at the normals, everything's facing properly. So half of the work is basically done. We have the normals. We could start copying the runes to these points. We can apply a copy to points. These are the runes. We can connect it here. Just disable the normals, disable the points as well. And these are the points where we want to copy them to. So they're too big. Let's go to 0.1. And now we have them. Now they're kind of aligned to the normals, but as you can see, we still haven't determined which way they're facing, because they can rotate freely along any one of these directions, because we only have one vector here. All we have so far is the normal vectors. Okay, and they are facing along those vectors, but we still need to control how they rotate along those axes. For that, we need to give it the up vector, and we need to calculate an up vector for each one of these. So let's see how we can take care of that. We know before that we used a temporary vector for calculating the cross product. Okay, we created a temporary vector. In this case, it was aligned with the y-axis of the world orientation, and we used this expression, and we're going to do exactly the same thing. We could actually copy it, but I'm just going to write it down again. PW to create a point wrangle, and we have the primitives. We need the temporary vector to calculate the up vector. So we need a variable vector type, and I'm going to call it temp v. It's going to be equal to some vector, semicolon, and that vector for now we're going to be using the x-axis. It's almost perpendicular to the normals that we have, so we'll try that one. Let's say 1 0 0. This will be our temp vector, and we'll say that our vector attribute up is going to be equal to the cross product between our normal and our temp v, semicolon. Great, so now we have an up vector. It's perfectly perpendicular to each one of these, but it's not actually facing the direction that we want. And the reason for that is because when we have a look at the runes, the y-axis of this object is facing up. So this needs to be actually facing towards the tip of the hammer and not towards the side. So we have two options. Either we rotate the object here, we can continue to apply rotations here to compensate for that, or we would have to do a bit more math. Let's keep the math to the minimum. I'm going to call this calculate up. And we have a valid up vector. It's fine. Let me just make sure this isn't showing. I'm going to control middle mouse button and just click on the up attribute so it doesn't show anymore. I'm going to also remove all of these. I don't want to copy anything from that. And as you can see, the problem we have right now is that the up vector was pointing to the side. The up vector was actually pointing to the side, and that's what's happening here. Okay, so this isn't the proper orientation. We can easily fix this if we rotate our object along the z-axis, let's say 90 degrees, and now it's facing properly.